Dear students, welcome and thank you for tuning in to another Stacks and Dynamics video with me, Dr. ALZUBE. We are going to continue our discussion about trusses, and in this lecture and in the coming videos, we're going to be talking about how to determine the forces in members of a truss using the method of sections. We talked about the method of joints, and we solved an example in the previous lecture of how to do so and find all the forces in the members of a truss. We're going to expand our analysis and knowledge about trusses and forces using the method of sections. First, why do we need this and why this is important? Why do we need another method to solve for forces in the members of a truss? We are building longer and longer and bigger trusses and often used to construct large cranes and large electrical transmission. What if you want to find the forces of a member that is in the middle of such a large structure? So to do the method of joints requires that many joints to be analyzed before we can find the force in the middle of a large truss. Let's say in a crane or electrical transmission towers. So what we need to do is actually to find another way, another methodology to do so. Well, luckily we have this one, and this is called the method of sections. So how does it work? The method of sections, a truss is divided into two parts by taking an imaginary cut as shown here at AA through the truss. And if I'm interested in the force on the CG member here, I would do an imaginary cut here, and I will separate the two parts, one on the left and the other one onto the right, and I will focus on analyzing one of them. And we usually use the part where it has the least number of unknown reactive forces, which is in other words the support reactions. When we do this imaginary section, we rely on the concept that since truss members are subject to only tensile or compressive forces along their length, the internal forces at the cut members also will be either tensile or compressive. Let's assume we have this member that we know that it has a tension on it, and we cut it in the middle. We created two smaller portions of the member. They are going to be subject to also tension forces as well, because internally we have tensile forces. When we expose them, they're going to continue being tensile forces with the same magnitude. Same happens for compression. If we have compression and we did a cut, we are going to have also compression if we separated the two parts. This concept is based on equilibrium principle and Newton's third law, which states that for each action there is a reaction equal and opposite in direction. This is what we're going to be focusing on and using if we would like to analyze big trusses. And we're going to solve a couple of problems actually together to see this in action. In the following video, I'm going to list and explain the steps we're going to follow in analyzing and using the method of sections to find the forces in members of large trusses. Thank you for watching. Until next video. Bye.